In our video tutorials about the WinForms dashboard, we've built so far the panel with charts and gauges. In our last video, we added the dock control to the application and placed the charts panel in a dock item. This is the final look of our dashboard. In this video tutorial, we will build the spreadsheet that contains all data. Here is our project. First, we must add the reference to the spreadsheet library. We have copied the libraries for all components of the WinForms pack in the References folder in our project. We need to add reference to the Spreadsheet WinForms DLL. Next, we will declare two class variables. The first one is the workbook view, which is the component that renders a spreadsheet. The next is the workbook itself. This is the component that you use to handle the data. Let's initialize now the workbook view and the workbook. We do this at the beginning of the class, before we start initializing the charts and gauges. We create a new workbook view and set a fancy font for it. We also create a new workbook and assign it to the workbook view. Each workbook needs to have sheets, which are of type worksheet. We can either access the worksheet that is currently added, or add a new one, if none are present. When we call add on the collection of worksheets, the method returns a new sheet. Now let's look at the members of the style property. The main interface is iStyle, and it declares most of the properties that you can use to customize the looks of the worksheet elements. iStyle is implemented by two classes that are specific to rows and columns: iRowStyle and iColumnStyle. Let's style our worksheet now. Styling is done through the Style property. All worksheet elements like cells, columns, and rows expose a style property. Let's get the style of all cells in the worksheet. We set the font to Calibri and the font size to 9. We specify 3 points padding on data in each cell, and we align the data in the middle. Regarding rows, we make each row to be 17 points high. For that, we have to get the style property of the rows first. What we've done so far is enough to style and render a spreadsheet. Let's add this spreadsheet to our dashboard and see how we've fared so far. We declare a new doc item called Spreadsheet Item. We initialize it. Its header is called Data, and we assign an ID to it. Let's dock it to the left. The content is the workbook view. What we are left now is to add it to the items of the doc control. Let's run the application. Here is our dashboard. The spreadsheet is docked to the left. We can move it and change its dock position. So far, everything works fine. Now let's add some data to the cells. First, we declare the Begin Init and End Init block, where spreadsheet data will be provided. This way, we avoid forcing the control to execute update and calculate operations on each row of data entry. We provide the data headers for our columns of data. The cells property allows us to access spreadsheet cells by their column and row indices. And here is the data so far. Now let's declare a few data arrays that hold the data for our spreadsheet. These are IDs, parts, inventory, and defect, as you might have guessed from the column headers. I'll paste the data for these arrays so we don't type it one by one. We will use the arrays to populate the columns of our worksheet. We will use again the data property of cell to assign the values from those arrays to the correct cells in the spreadsheet columns, which we've marked with the header labels, ID, part, and so on. We do this in a cycle. Let's check the result. Here it is. The data is partly hidden in the second column, but there is an easy way to fix this. First, let's look at the original dashboard. As you can see, the pie chart renders the data from the spreadsheet. These are the IDs of spare parts as outer labels and the inventory as pie data. We will do the same in our dashboard application. First, we declare a new list with strings. We need to convert the IDs to strings because they are double values. Then we change the pie series constructor to use the inventory as data and the new list with strings as outer labels. And the pie chart now has the correct data. Let's fix the column size now. The spreadsheet has a method, resize columns to fit. Let's find it in the online help. It is a method of workbook view. We call it for our 4 columns, and let's check the results. Yes, the column data is not hidden now. If we look back at the initial dashboard, we see that the spreadsheet data we just defined is used also in the line chart, the oval gauge, and the 2 linear gauges. We will use it in our sample as well. Let's edit the data for the line chart first. We delete the current data and leave the lists empty. Then we cycle through all values in the defects list and assign them to the Y data array. We have to multiply the data with 100 to convert it to percents. Let's look at the axes intervals and see if they need adjustment. The y-axis will be from 2 to 20, given that the defects are a small percent. The chart looks alright now. Let's calculate the data for the gauges. We need to have the defect sum, the min and the max percent value. We declare 3 new variables, which we will use to calculate the data for the gauges. We sum each defect value and we check to see if the current value is smaller or bigger than the current min or max value. We set the pointer value of the oval gauge to be the sum of defects multiplied by 100. Let's see if it looks all right. Yes, here it is, exactly as we want it. Let's assign the min and max defects values to the two linear gauges. Now we will assign the max defects variable to the value of the pointer for the first linear gauge. It renders the max amount of defects in the current inventory. Then we do the same with the min defects gauge. And now our dashboard looks well. Let's get back to the original dashboard. In it, if we change a value in the spreadsheet, the dashboard to the right gets updated. We are going to implement this real-time update with an event. We handle the in-place edit ended event for workbook view. Let's look the event in the online documentation. It has arguments of type in-place-edit event args. From the members of the event data, we will use the item property to get the cell that was edited. So, we get the edited item and we check if this really is a cell. If it is, we have to check if it's on the correct row. The rows span from 3 to 14. Since the spreadsheet counts them from 0, the indices will be from 2 to 13. We try to parse the data of the edited cell, and if the conversion was correct, we update the respective element in the IDs array. After we've done this, we need to prepare a new list with outer labels and create a new pie series to replace the existing one. Finally, we call the refresh method of the dashboard to update the control. Let's run the sample and see how we've coped so far. We edit the ID and the pie chart really gets updated. We will add now another case for the third column. The code is almost identical, but the data is for the inventory rather than the IDs, which are indeed the outer labels. Now if we change a value in the ID or inventory column, the change is reflected on the chart. Updating the line chart and the gauges is similar, and you can see it in the source code, which is available for download. That was all for this tutorial. Thank you for watching, and thank you for your interest in MindFusion Developer Tools.